December 1992, LaGrange, Illinois. Somewhere inside the largest locomotive factory ever built in America, a bell rings for the very last time. For 56 years, that bell had announced every locomotive rolling off the assembly line, and at the peak of production, you would have heard it 10 times a day, sometimes more. But on this particular morning, the bell rings once. The workers stand in silence, watching a commuter locomotive for Chicago's metro system roll through the doors, and that is it. The doors close behind it, and an empire that once controlled 80% of the American railroad industry is essentially finished. Now, here is what makes this story so strange. This factory was not brought down by foreign competition. It was not destroyed by a recession, and it was not even undone by bad management in the traditional sense. This factory, this entire company, was brought to its knees by a single locomotive model that was supposed to save it. And the truly painful part is that everyone inside those walls knew exactly what was going wrong. They saw it happening in real time, and they could not stop it because the decision had already been made at levels far above the factory floor. The company was EMD, Electromotive Division of General Motors, and for decades they were the undisputed kings of the American locomotive industry. When railroads across the country decided to abandon steam and switch to diesel in the 1940s and the 1950s, EMD was there with the right product at exactly the right moment. By 1953, they controlled nearly 73% of the entire market, and their competitors were not even close. The secret to their success was straightforward. They built locomotives that worked, and they built them consistently well. Their dominance rested on reliability. Their SD-44-2, introduced in 1972, became legendary among railroad engineers because you could run that machine hard, day after day, year after year, and it would just keep going without complaint. Railroads across North America ordered over 4,000 of them, making it one of the most successful locomotive models in the entire history of American railroading. Maintenance crews loved it because parts were standardized and repairs were simple. Engineers loved it because when you climbed into that cab at 4 in the morning, you knew the locomotive would do exactly what you asked of it. And EMD loved it because the orders kept pouring in faster than they could fill them. But then something shifted in the competitive landscape. General Electric, which had been making locomotives for years without ever seriously threatening EMD's dominance, started gaining real ground with its -7 series in the late 1970s. These machines were producing 3,600 horsepower, compared to the SD-42's 3,000 horsepower, and they came with financing and maintenance packages that made railroad accountants pay attention. Suddenly, executives at the major railroads started asking uncomfortable questions about why they were still buying EMD when General Electric was offering more power for competitive prices. The pressure on EMD to respond was enormous, coming from customers, from competitors, and from General Motors executives in Detroit who wanted to see numbers improve. And this is where the trouble begins. Because instead of taking the time to design an entirely new engine that could handle higher power output safely, EMD's leadership decided to push its existing 6145 engine beyond what it was originally designed to do. The SD-42 ran at 900 revolutions per minute and produced 3,000 horsepower, which was well within the engine's comfortable operating range, a sweet spot where everything worked in harmony. The new locomotive, called the SD-50, would run at 950 revolutions per minute and push out 3,500 horsepower, squeezing an extra 500 horsepower from the same basic engine design. On paper, this looked like a reasonable engineering step, an incremental improvement that would keep EMD competitive. In reality, it was a disaster waiting to happen, and the engineers on the factory floor knew it. The first SD-50s rolled out of LaGrange in May 1981, and the problems started surfacing almost immediately. The engine was being pushed past the limits of what its fundamental design could handle, and mechanical failures became routine in ways that shocked even the most experienced maintenance crews. Crankshafts were cracking under the increased stress of higher revolutions per minute operation. Electrical systems were malfunctioning constantly, with reports from CSX engineers describing headlights that would not turn on, cooling systems that overheated without any warning, and transition failures where the locomotive would simply stall during the shifting of electrical current between traction motors, leaving fully loaded trains stranded on the main line. According to accounts from workers at the factory, locomotives were being written up with 25 or more defects per unit before they even left the plant for customer testing. 25 defects on a brand new locomotive that was supposed to represent the future of the company. The railroads noticed, of course they noticed, because they were the ones dealing with the breakdowns and the delays and the maintenance headaches. Where EMD had sold over 4,000 S-Story 2 locomotives with railroads practically begging for more, they managed to sell only about 500 SD50 locomotives total. The sterling reputation that EMD had spent 50 years carefully building was crumbling with every breakdown report that crossed a railroad executive's desk. And while EMD was struggling desperately with their problematic new locomotive, General Electric was quietly perfecting their Dash 8 series, which featured something genuinely revolutionary: microprocessor controls that made the locomotive smarter, more efficient, and significantly more reliable than anything EMD was currently offering to the market. In 1987, for the first time in more than half a century, General Electric sold more locomotives than EMD did, and they never looked back, not once. Every single year from that point forward, General Electric outsold their humbled rival, often by margins of 2-1, sometimes 3-1 during particularly strong years. The market share numbers tell this painful story better than words ever could. EMD went from controlling 80% of the American locomotive market to holding just 30% by 2007, while General Electric climbed steadily to 70% and showed no signs of slowing down. The response inside EMD to the SD50 catastrophe was almost tragic in its irony. To fix the crippling reliability problems, railroads started downgrading their expensive new SD50s back to 3,000 horsepower, running them at 900 revolutions per minute instead of the problematic 950 revolutions per minute. They were converting their costly new locomotives back to the exact same specifications as the SD40-2 that the SD50 had been designed to replace. CSX officially classified these downgraded units as SD50-2s. Norfolk Southern went even further, completely rebuilding their SD50s with SD40-2 components and redesignating them as SD40Es. Millions upon millions of dollars were spent developing and purchasing a supposedly superior locomotive, only to strip out all the upgrades and return to what had already been working perfectly fine. The closure of the LaGrange factory happened in painful stages over several years. First, the assembly lines went quiet in 1991, with locomotive production moving to a newer facility in London, Ontario. Then the workforce, which had once numbered over 14,000 proud employees at its absolute peak, shrank to just a few thousand clinging to what remained. The ceremonial bell fell silent in late 1992. By the year 2000, the wrecking crews finally arrived with their heavy equipment, and the massive building that had produced more diesel locomotives than anywhere else on the entire planet was systematically reduced to rubble and memory. Workers who had spent their entire adult careers walking those floors could not bring themselves to watch the demolition.